In this section, we unpack the physics behind escape velocity, explore how the same principle can be applied in solving basic problems in escape velocity. Listen very well and also channel your question to our channel, ask questions and make references. And every question we post will aptly be responded to. Let's go to the teaching right now.
Escape velocity. What is escape velocity? Escape velocity is the minimum velocity required by a body to completely escape the influence of gravitational force. For example, when a body leaves the surface of the earth, such a body has escaped the influence of acceleration due to gravity. So, example of such a body that can completely escape the influence of gravitational force or acceleration due to gravity is satellite. So, when we launch satellite into space, such satellite is no longer under the influence of acceleration due to gravity or gravitational force. We can also estimate the magnitude of the escaping velocity by deriving the formula for that. Of course, we know that work is done for releasing such a body into space. And when we equate that work done as energy expended, we can derive an expression for escape velocity. So if we say work done equals to energy expended, now let's say work done, energy expended is equal to what? Work done. For in terms of formula, the energy expended in this case, because the body is escaping the surface of the air. Such energy is what? Kinetic energy. So kinetic energy is also equal to what? WD, work done. The formula for kinetic energy given by what? Given by half mv squared is equal to what? Force times distance. In this distance, we're going to use arrow. In this case, as our distance. And we can again represent. We can also rewrite this as mv squared over 2 is equal to what? Recall, in this case, the force exerted on such body now, since the body is escaping the influence of gravitational force, will be given by gm1 m2 over what? R squared. So multiplying by the original R. But at this point, we have mv squared over 2 is given by, of course, this arrow will remove one here, will be left to what? gm1 m2 over what? R. Recall, we are deriving an expression for escape velocity, so we are going to leave v squared the subject of the formula. So let's multiply that out. We're having what? mv squared r on cross multiply. That is like this. On cross multiply, we have mv squared r is equal to what? 2gm1 m2. So dividing both sides by mv squared r over what? mv is given by what? 2gm1 m2 over mv. Now, sorry, not mv, mr. Recall we're interested in what? We are interested in v, so it will be mr. Here what? mr. So r will resolve itself, m will resolve itself. So we left with v squared because we're interested in v. So here m will take out one of the n. So here we left what? V squared is equal to 2gm over r. 2gm over what? R. So at this point, our v is equal to what? Square root of 2gm over what? R. So the square root of 2gm over R. So this becomes our expression for finding the value of what? Escape velocity. V is equal to what? Square root of 2gm over R. Of course, supposing you are not giving acceleration to gravity, Because this final expression now is V equals to square root 2gm over r, where g here is gravitational constant. If you are not, if for example you are not giving gravitational constant, you are giving acceleration with gravity, we can again derive an alternative formula for finding the escape velocity of a body escaping the influence of acceleration with gravity on the surface of the earth. So we can do that by bringing back our expression. Recall our expression for finding the mass of the earth. Recall that expression? How many of you recall that expression? That G equals to what? G NE over what? R squared. Remember that expression? G equals to what? Gn subscript E over what? R squared. That's the expression for finding the mass of the earth. So with that, we can derive an alternative expression for escape velocity. Let's do that again. So our final value is V is equal to what? Square root 2gn over r. Well, here, recall, since the body is escaping something on the end, we can write subscript NE. And the V, we can say V subscript E, escape velocity. So V is equal to square root of 2gn over r. Now, but we are going to use but G is equal to what? Gne over r squared. So we recall that expression, right? That was expression for deriving the mass of the earth. When we did derive an expression for relationship between what? Gravitational constant and acceleration due to gravity. Now, from here, we can now move on to what? Make ME, which is mass of the earth, is subject to the formula. And come back to this expression and replace the solution you have gotten with ME here, so that we can be able to get an alternative formula for calculating the escape velocity of the body escaping the surface of the earth. Let's do that. Now again, we say that our VE, okay, let's first of all make ME sorry the formula here. Now we have G is equal to what? Gn subscript E over R squared. Suppose we make our G over 1 here, when you cross multiply, we're interested in ME, making the M, so we have Gne is equal to what? Gr squared. So make divide both side by G. You have Gne over what? G equal to Gr squared over what? G. So we're talking about big G here, big G. Not small g, big G. So big G will resolve big G, left with M subscript E is equal to what? Gr squared over capital G. So this expression, which is solution to what mass of the air, will now come here and replace. We replace ME here. So we replace ME here. So with that, we now have our VE, our escape velocity V will now be what? Square root of 2G NE, let's start with E, let's start with E over R. Of course, we will not write over R yet. We write in place of NE, we are going to write times. We're going to write times the solution from ME, which is what? Gr squared over G. All over the R like that. So G will cancel out G. So G will cancel out G. So I'm going to write here. Let me divide the body into 2 here. So G will cancel G. So we left what? V is equal to square root of 2Gr squared, 2Gr squared over R. Again, this denominator R will resolve one of the R here. So if you left what? Escape velocity VE is equal to what? Square root of what? square root. We are still having g that is spreading. So okay, this is supposed to be small g, not big g. Gr squared. So we'll now be left with 2gr. So this expression, v subscript e, become an alternative expression for finding the escape velocity of the body. Now we now have two formulas. So what are in summary now? Let's place the formula in summary. Now in summary, the first formula is what? V equals to what? Square root of 2g. Square root of 2gn over what? R. That's one written in terms of what? Gravitational constant. We have V is equal to what? 2gr. The one written in terms of what? Acceleration due to gravity. So with these two expressions, whenever you are given a problem based on escape velocity, the parameter will determine what to use. The parameter will determine what to use, whether you are using v equal to square root of 2gm over r. Don't forget that this square root is covering everything. The square root is what? Covering everything. So that is it. So let's take example now. Let's take example. There's an example on the board. We are asked to calculate the escape velocity of a satellite from the Earth's gravitational field, given that g is 9.8 meter per second square and r is 6.4 times 10 to the power 6 meter. Solution. Now in solution, what is the first thing you do here? What is the first thing you do? Now what is the first thing you do? You bring out the parameter. What are the parameters given now? We are given that you have to find what you are asked to find the first thing, right? We are asked to find the escape velocity. We have to find what? The escape velocity. We have to find the escape velocity. So our V, there's a question mark there. Now we have what? G is equal to 9.8 meter per second square. We are given radius of the Earth, r, is equal to 6.4 times 10 to the power 6 meter. So these are the parameters that is given to you. Now we have VG and R. VG and R, that means that we are going to use the second formula from the summary. We have number 1 and number 2. We are going to use V, escape velocity equals to square root of 2gr, where g is acceleration to gravity and r is what? Radius of the air. It can be small r or big r. Whatever case. Now in this case, we substitute escape velocity is given by square root of 2 times 9.8 times what? R. R is what? 6.4 times 10 raised to power 6 meter. No, there's no need of putting meter here. Now, when you evaluate using your calculator, our final answer will be 12.54 times 10 raised to power 7. Unit of escape velocity is what? Meter per second. Meter per second. So escape velocity is what? Meter per second. So at this point, you can go to your textbook and solve problems based on escape velocity. But peradventure, you encounter any problem you cannot solve, go to the comment section. You can type that question in that comment section, and you'll be ably responded to. So we close this session now.
We have come to the end of this session. Share with loved ones, friends, and family. See you in the next session.